Okay, the paper is open for questions.
Thank you. We are now open to question or comment.
The slides before last slide, in the slide before the last, you show the measured and calculated result. What is the main reason it makes a discrepancy between measured and calculated results?
The question is the discrepancy between the experimental calculated result. Is that right?
Yes.
In this slide, we measure the reaction for inverter circuit using the substitute current of the MOSFET. But in our models have some assumptions. For example, we use as sectors to cover the periods. After the bipolar transistor turned on, the rest of the trigger current is used for the base current of the bipolar transistor. So in these sectors, this area is not used in the actual device. So our calculate is calculate is below this line. It's some kind of margin to design this one. Second reason, or at the same time, the second reason we took account of the layered pattern size or H parameters. So we use the angle to theta. It is some kind of discrepancy. For further calculations, we use only the theta values that towards more agreement with the experimental ones.
Your latter explanation, I couldn't understand clearly. Sorry, latter part. I couldn't understand clearly.
Latter part?
Latter part.
Oh, yes.
Former part is, yes, I understood.
Yes. First, before the bipolar transistor turned on, the edge potential increase is the same. But after the bipolar transistor on, the rest of the trigger current in the sector are used as base current. So the angle 2 theta is too large. I understand here.
So current path is restricted in the area.
This direction, but these parts after the bipolar transistor, so these parts current used as only the base current. This is our assumption. This is our assumptions. So we must modify more accurately is my future bias here.
So if you try to calculate this value using some numerical simulation, do you think the result between measured and calculated result, discrepancy between the calculated and measured result is close? Will be close?
Calculate simulation?
If you calculate using the numerical method,
analytical method, using analytical method, only analytical method.
Your work is analytical.
Yeah.
Yes, I understood. But if you try to calculate such a value using a numerical method, the discrepancy between the measured and calculated will be close.
Smaller.
Smaller?
Yes. I think so. Yes.
So the point to your presentation is the method is based on the analytical way.
Yes.
It's an important point.
That's an important point. Easy to understand. In the actual layout, the distance from edge here to from the real contact to edge is different in the manufacturing, and also the device parameter is different from the calculating method. So I try to generalize the guidelines.
Okay. So I'd like to recommend you. You have to strongly press. Your method is analytical. But in your presentation, I couldn't catch you press such a point. I couldn't recognize. You pointed out the point.
He didn't mention that.
Yes.
Okay.
Thank you.
It's a very important, I think.
So this is a general method regardless of the type of process technology. You think? Okay, other questions?
I have a question. From your Rajab model, which do you think the most dependent parameter in induced Rajab?
Question is calculate result is depend on to the parameter. Which parameter is most dependent?
Most important.
We estimate, we calculate the important parameters. First, as I showed earlier, the lowest parameter lowest and J0 is very important parameters. For example, this value is set to double. The radius A is reduced about to decreases 20%, 30%. Next parameter is the size, H parameter. This parameter is a distance from the real contact to the anywhere edge. So when H parameter is changed to this residential 50 micrometer to 30 micrometer. So the character radius A is decreased about 20%. It's very important. But the pattern size B is not so important. Our calculation, the B is the web contact radius and from 1 micron to 2 microns. B is a double. The calculated radius A decreased only 5%. That's all. This structure,
the PWL isolated structure, the Rajab limit is very low. So could you comment how the Rajab limit is decreased?
Usually, device structure is changing to improve the Rajab stability. For example, is the PWL sheet resistance is decreased. But for bisimultaneously resized bipolar transistor, it's very important to get a higher performance. So this is a trade-off. For the reactor designer, using these calculations, where contact placed very close. That's all.
Just ask you a question. In slides,
What's the name of the slide? What's the?
Rajab model slide. The distance between, I think the distance between N plus diffusion area, P plus diffusion area.
Yeah.
How does how is this distance is what do you think of this?
Do you think this
Program.
distance has an effect on the?
How does this distance affect your model?
The distance from the N plus issue to the big system,
Yes.
right? Yes, you can listen.
Yes.
The spacing between this is very important to estimate the lattice stabilities. First, this resistance related to the current gain of the bipolar transistor first. So the main point is like this one.
But how do you take this spacing into account in your model?
We cannot take into account in our models, but the spacing difference is very important. The effectiveness of the spacing is as the current gain of the bipolar transistor. The current gain of the bipolar transistor is very important to depend on the spacing. Usually, the spacing usually their designer took the spacing very closely. Don't take the spacing very closely to reduce the latch-up susceptibility.
But okay, if the spacing affects the latch-up susceptibility, then it should the value A that you present should have some parameter depending for that space. There should be a parameter for the spacing. It should include a parameter for the spacing for an accurate estimate.
What does it mean? I don't understand. Sorry, I don't understand what you.
You mean the spacing, the space between N plus and P plus affects the beta N?
Yes.
So it's included.
Yes, yes.
Effectively, it's
Yes,
included in the...
yes, but the spacing, the E plus and NLH spacing does not include.
Is not included.
It is not included.
So if you change the spacing, then A will change, correct?
Pardon?
If you change the spacing between the N plus and P plus layers,
Yeah.
then the value of A should change.
Yes, yes, yes.
But you didn't include that in your model, right?
Beta n.
Beta N includes that idea.
Yes, yes.
Takes that into account.
If the spacing if the spacing very closer.
I see. So it is included, actually. Okay. Yeah, you answered your own question, but he didn't answer the question. You should say.
Any questions or comments?
Sorry, I don't know. I don't know well this field, so please teach me. If designer want to determine A, which parameter? Okay, I understand. The parameter the designer have to know before he designed. You showed in your slide, and these parameters are shown in your slide.
Yes.
But for example, beta n,
Yeah.
is it estimated before fabricate this structure?
Is it possible to
Yeah, is it possible
to estimate?
to estimate?
Yes, yes, yes. Sure.
Sure. Okay.
But we cannot include non-linearity such as current gain dependent on the current in general. So, but we cannot include the non-linearity of the current gain or the when we use the annual type single structure, the conductivity modulation is very important. So, but that is presented by Dr. Nitz, Toshi Corporation, about 8 years ago. We don't include this one, this effect. So it is towards higher lateral humidity.
Pardon, it's toward. I see.
If we take account of the non-linearity, it towards the higher lateral
I see.
humidity.
There's one point I didn't understand, just the basic structure of your presentation. You discussed injected currents in the beginning. Then you switched to a uniformly generated current for the model.
Yeah.
So I can't, why, isn't it important to take into account injected currents in deciding the spacing? I don't quite understand the point. This model only accounts for uniformly generated currents.
Yes. Usually, local trigger current is determined by the test structures only. We can we could take data of the trigger current versus the specific speed, but uniform trigger current is not determined.
Cannot be determined.
Yes.
I see.
So, and also the effective PV shunt resistance is very different from that of local electric current because of the mechanism very different. Yes.
Mm.